In this video, I'm going to be talking about solving proportions. So a proportion is going to be two ratios set equal to each other. So on the left we have the ratio 10 to 15, and on the right we have the ratio 6 to x, some unknown value. So given this proportion, we're saying these two ratios are equal to each other. So we can solve them by setting the cross products equal to each other. So here's how this works. We take 10 times x, so 10x, and then we take 6 times 15. 6 times 15. So we can solve this for x because 10x equals, let's see, 6 times 15 will be 90. Then it looks like we can divide both sides by 10. So x equals 9. So what we're saying here then is if we plug 9 in for x, 10 over 15 will be the same as 6 over 9. Well, let's just take for a moment, let's simplify each one of these fractions. Right, so 10 over 15, we can divide 5 out of each one of those factors. When we do so, we'll have 2 over 3. Similarly, with 6 and 9, we can divide a 3 out of both of them, and we'll get 2 over 3. So hey, look and notice that both of these fractions reduce to 2 over 3. So we know they are proportional to one another. So when we're trying to solve proportions, maybe it's pretty obvious what this value of x is going to be. Maybe it's not so obvious. But if you're unsure what it is, you can do cross products and then set them equal to each other and solve for your unknown value. In this second example, we have the ratio 3 divided by m equal to the ratio 3.5 divided by 14. So again, this proportion is just two ratios set equal to each other. And in order to solve for this missing value, we can go ahead and do cross products and set them equal to each other. So 3.5 times m is the same as 3 times 14. Okay, well, 3 times 14 is going to be 42. And then, in order to solve for my m right there, I'm going to go ahead and divide both sides by the 3.5 right there. So when I do that, you can use a calculator. I mean, you could multiply the top and bottom by 10 and get 420 over 35. I mean, there's several ways you could do this, but no matter how you do it, you're going to get m equals 12 for your answer. So what we're saying here is if we plug 12 here, we have 3 over 12 equals 3.5 over 14. Well, if we go and reduce both of these, I get 1/4 here, because I can divide a 3 out of both of those terms. And wow, I don't really like having this decimal here. Again, you could do some things to manipulate it, but you're going to find out if you multiply 3.5 times 4, you're going to get 14 there. So actually this reduces to 1/4 as well. So 1/4 equals 1/4, so we know that m is 12. In this next example, we have x plus 2 over x minus 1 is equal to 10 over 4. Well, we have x that we're solving for, but it's actually in multiple locations. So I think my only choice here is to do cross products and set them equal to each other. Be very careful here, because when we're multiplying 10 times this quantity x minus 1, we need to put that x minus 1 in parentheses since these multiple terms. And that's going to equal 4 times, again, this is a binomial, multiple terms, so I'll put x plus 2 in there. So now, in order to solve, we need to distribute first. So 10x minus 10 equals 4x plus 8. And then it's just a matter of solving this equation. So we can subtract 4x from both sides to get rid of those. We can add 10 to both sides to get rid of those. So I have 6x equals 18. So it looks like my value of x is just going to be 3. Which means if I plug 3 in over here, 3 plus 2 is 5, 3 minus 1 is 2, equals 10 over 4. Yeah, and if I was going to reduce this fraction, I would get 5 over 2, which is the same as the fraction I have over on the left. So I know that my value for x as 3 is going to be correct. In our fourth example, we have the ratio 6d over the quantity d plus 6. And that's going to be equal to 12 over 5. And again, since we kind of have variables in multiple places, like really our only choice is to go ahead and use these cross products. So 5 times 6d equals 12 times, and then we got a quantity, so we got to put in parentheses, d plus 6. Okay, so multiply through there and distribute through there. 5 times 6 is 30d, and then when we distribute 12d plus 12 times 6 is 72. Okay, so I can subtract 12d from both sides, and they cancel over here. And it looks like 30 minus 12 should be 18d equals 72. And that's nice. Let's just divide both sides by 18. And my value for d is going to come out to be really nice at 4. So again, like the other examples, let's plug it in. So 6 times 4 over 4 plus 6. And we're saying that's the same as 12 over 5. Well, 6 times 4 is 24 over 4 plus 6 is 10. And if we reduce this fraction, I can take a 2 out of each one, I'll get 12 over 5. Look at that. So again, my value of d was 4. When I plug it in, I get equal ratios. In our fifth and final example, I have negative 2j over 9 is equal to the quantity j minus 1, and that's divided by negative 3. So again, we kind of have our variable in multiple places. So let's go ahead and cross products again. So negative 3 times negative 2j. So negative 3 times negative 2j is going to be equal to, and then we have 9 times the quantity j minus 1. Okay, well let's multiply here and distribute there. Negative 3 times negative 2 is positive 6j equals 9j minus 9. And then I put my j's together by subtracting 9j from both sides. So negative 3j equals negative 9. So I could easily divide both sides by negative 3. So this negative 9 divided by the negative 3, j is going to equal a positive 3. And again, I can plug them back in. So negative 2 times 3 over 9 equals 3 minus 1 over negative 3. So this ends up being, let's just put this stuff down here, negative 6/9 equals 2 over negative 3. So they each one have a negative, and 6 over 9 will reduce to 2 over 3. So we know that the value 3 for j is going to work in this proportion as well.